Today we study Chapter 1, Section 7. So in this section, we're going to learn how to translate verbal description into mathematical expression, and then how to solve interest problems, how to solve mixture problems, how to solve uniform motion problems, and how to solve constant rate job problems. Okay, that's the 5 objectives for this class. So before we look at any specific topics, let's just quickly overview the modeling process, how we model a word problem. So whenever we have a word problem, first we would like to put into word, okay, verbally describe the problem. After we're able to verbally describe the problem, and then we need to use mathematical language to represent it. And then we can set up a mathematical model. And then we solve that mathematical problem to get a solution. Okay, that's the general process, but it's not done yet. After we get a solution, normally we would like to verify the solution by checking whether mathematically, okay, no any calculation error. And then we also need to double check whether it's matching the verbal description. And then finally, we apply back to the real problem, see if the solution matches, okay? So that's the whole process, how to modeling. All right, let's look at the first section, how to translate verbal description into mathematical. How to translate verbal description into mathematical expressions. Normally, translate verbal description into mathematical expression, we need to looking for the keywords, okay? And then those keywords actually indicate the type of operation mathematically. For example, the keywords like sum, right, summation, or add to, exceed, those all indicate addition mathematically, okay, addition. And then subtract, right, minus, less than, those kind of keywords indicate subtraction, right? And then times, multiply, or the keywords product, okay, those are the indication of multiply. And then divide, just keyword divide, and then divided by or divided into, there are 2 different ones, okay, numerator, denominator will be different. And then the ratio, okay, those are all the keywords indicate the mathematical operation is a division. And then the keywords like equal, we need to translate mathematically to equal sign. All right, so now let's look at some example. A, for uniform motion, the average speed of an object equals the distance traveled divided by the time required. So for this one, can you identify the keywords? Equals, that's translate to equal sign, right? Divide, that's translate to the division. And then left-hand side of equal sign, right-hand side of equal sign, you just have to use the variable to represent it in order to translate into mathematical expression, okay? So average speed of an object, let's use R to represent. The distance traveled, let's use D to represent. And the time required, let's use T to represent. And then after we do that, we can easily translate this sentence into mathematical expression. R equals D divided by T. All right, so let's look at another example. If let X denote a number, and then it says the number 5 times as large as X. So how to represent 5 times? 5 times, the keyword times indicate this is the multiply, right? So it's 5 multiply X. We just write as 5X. The number 3 less than X, so keywords less than, does indicate it's a subtraction. So what subtract what? 3 less than X, so 3 less than X, right? So it's X minus 3. The number that exceeds X by 4, addition, doesn't matter which one first. So exceed is indicate is the operation plus. So we can write as X plus 4 or 4 plus X, doesn't matter, okay? For addition, you can switch the order. The number that when added to X give 5. So this need a little bit logic here. Okay, if we think the number we don't know, okay, when added to X give 5, which is equals 5. So if we want to know this question mark, this number, we should subtract X on both sides of the equation, right? So 5 minus X. That's how to translate this sentence or verbal description into a mathematical expression. So these slides you may feel familiar with, right? You already see that in Chapter 1, Section 1, when we study how to apply a linear function into word problem. So that's exactly the same steps, identical, okay? So since we already learned this, and then I won't waste the time to repeat it. So basically, you know, if I put in short, the first step, you need to identify what we're looking for. And the second step, you need to assign the variable. Okay, first step, what we're looking for. Second step, assign the variable. Third step, you need to set up the mathematical model. Okay, translate the known facts into mathematical expression and then build up the model. Step 4, solve the model. Okay, solve for the variable and then check the answer. All right, so now let's look at example, solve interest problem. Simple interest formula, I equals P times R times T. I represent the interest made from that investment. P represent principal or initial deposit. R is the interest rate. T is the time in terms of years. Okay, how long that investment lasts. I equals P times R times T. All right, so now let's look at this financial planning problem. It says Sandy has $70,000 to invest and wants an annual return of $2,800, which requires an overall rate of return of 4%. She can invest in a safe government-issued certificate of deposit, but it pays only 2%. To obtain 4%, she agrees to invest some of her money in non-insured corporate bonds paying 7%. And the question is, how much should you place in each investment to achieve her goal? So let's follow that 5-step process, okay, procedure. So first step, we need to identify the unknown quantities, right? What we're looking for. How much invest in each, right? So how many unknown quantity here? If you read a problem, we have two different types of investments involved here, right? One is the CD, one is the bonds, right? So we're looking for how much invested in CD and how much invested in bonds. So we have two unknown quantity here. We're looking for the money amount buying the CD, money amount buying the bonds. Does that make sense to you? Okay, after read this problem, we identified, okay, two unknown quantity. That's what we're looking for. All right, second steps, we need to assign letters. So since we have two unknown quantity, we can let either one be x, and then the other unknown quantity we can represent in terms of x. Okay, for example, if I assign Sandy invest X dollar buying CD, and then how much she will invest the money into bonds, we know the total money she has is 70,000. So if X dollar buying the CD, and then the rest out of the 70,000 will be buying the bonds, right? So how to represent the rest of the 70,000? We use 70,000 subtract X. Is that right? So that's the second step, right? The third step, we want to translate the known factor into mathematical expression, right? So here, what we know the CD pays 2%, right? Pays 2% interest rate. And then the bonds paying 4% interest rate. Is that right? And we know the total interest made from the total 70,000 investment is $2,800. All right? So remember how to calculate the interest. I equals P times R times T, right? So how much interest we made for the CD? You should use principal times interest rate. We assume T is just 1 year, right? Annual return. So T equals 1. Okay, so use principal times R. Basically, T is 1. We can, ignore any number times 1 is the number itself. So P is the X for the CD investment, and then R is 2%. So we use X times 2%. That's how much interest made buying the CD. And then similarly, we use principal 70,000 minus X. This is how much invested in bonds multiply interest rate bonds making, right? And then these two interests add together, that's the total interest made from the 70,000 investment. So that's the mathematical model we can build based on the known factor, right? So step 4, we solve this linear equation. So we simplify 2%, that's 0.02x plus 70,000 minus x times 0.04, right? Okay, multiply. I use star to represent, so you won't misunderstand that's a variable x. Okay, this is the x. This is the multiply symbol. That's add together equals 2,800. Okay, further simplify. 0.02x plus 70,000 times 0.04, distributive property, right? I try to eliminate this parenthesis. Oh, I'm sorry. Did I make a mistake? Sorry. The bonds paying 7%, okay? Not 4%. I'm sorry. 4% is overall. So 7% here. Okay, the bonds paying 7%, right? Sorry, I made mistakes. So 70,000 times 0.07, we got 4,900. And then minus x times 0.07, that's minus 0.07x equals 2,800. All right. So now we combine the variable term, right, on the left-hand side, and then constant term, we subtract 4,900 on both sides of equation. So what we have, let me move here, no space. So I got negative 0.05x equals negative 2,100. Negative sign cancel out, right? And then both sides divided by 0.05. So we can solve x equals what? Use your calculator. 42,000. So x represents how much money invests in the city. Okay, and then how much invest in the bonds? Use overall investment, 70,000, subtract 42,000, and then we get 28,000. Okay, and then we can verify the solution and see interest made by buying the CD. Okay, 42,000 times the CD paid 2%. How much interest made from the CD investment? We get $840, right? And then 28,000 times 7%, that's the investment buying bonds. How much interest buying bonds we make? That's $1960. And then let's add this together. 840 plus 1960, is that the same as 2,800 overall annual return? Is that right? Yeah, that's 2,800. So we just verify the question. That's correct. And the book organized the whole table in whole problem into a table. Okay, you can look at it. The process and the logic is the same as what I did, but my logic is I try to show you the step-by-step how to use the procedure, okay, to solve the problem. And then if you would like to put in a more organized way, put the table like that, that will be better. Okay, so it's up to you. But either way, we get the same answer. Okay, I like this table a lot. Just put in a more organized way, and then you can easily check where each step's coming from. So that's the investment type of problem. And then the next slide is verify process.